Hello guys, my name is Sergey Nail3D and this is my developer log. And in that video I would like to compare PhysX engine, the two PhysX engine which is available in Motion Builder by default, and the one new that I'm using in my project, and it's a Newton PhysX engine. It's an open source free PhysX engine, and I will give a link to this project on GitHub in the description of that video. So let me start from the sample scene. In that competition I would like to use let's say 1000 of cubes, and they will just lay down, and that's all. And just to compare the rate, computation rate, that evaluation rate and frame rate, what we have. I think frame rate should be quite the same, just it can be depends on evaluation rate only in case if we have some synchronization. If the evaluation rate is less than frame rate, it probably will give us a visible performance issues, so it will cost us a frame rate as well, probably because of synchronization. So okay, let's start from the one cube, and I will make 1000 of them, and I will use just a simple plane. It will be my ground. I will make some angle to make it a bit bigger and on some angle. So to make 1000 I will use some special array tool. So it will be like 10 by 10 by 10 and 4 on each axis. So it will make me this is probably 1000 of cubes. Alright, so the next task is to select all these 1000 of cubes and to apply a physics property as the rigid bodies. Right, yes. Now it's a cube. So now I'm applying the physical property of rigid body. Right, so it's active, and I keep all the parameters by default. I don't want to change them at all. Alright, so that's we have 1000 of rigid bodies. We have the floor, so I think it's quite ready to have this test. So let's go to solvers. First of all, I will add the default solver. It's a physical solver which we have which is available in Motion Builder by default, and I go to properties. So let's start and test all the subjects with the ODE engine, and I would like to apply this ground to use it as the collision mesh. Okay, so now let's try in live mode. So as we can see, the performance is about 183, but the number of samples is not enough for such a quick animation, or we need to change the world scale. I think it also can be a reason. So let's change world scale to 0.1. So oh no, it's worth it. So I think it should be greater, like 10 maybe. Okay, so now it's we see better result. There is no cubes which going through the collision plane, but the evaluation rate is 22, and of course it produced the synchronization problem and decrease our frame rate. So I can't say that it's real time. It's only cubes. There is no characters and nothing more than just cubes which are going down. And if we see the utilization of my processor, it seems that it's utilized just for it's not utilized the full processor, maybe. No, it's not computing when I'm switching. But anyway, we have quite low performance, and let's try to use another engine. So I'm going to solvers and switch to PhysX. So now I'm going to the triangle mesh. Okay. So here probably in our physics calculations the ground is not taken in account. So maybe I need just simply to remove it to have collision maybe with the with the 0. So here is a bit much better, like we have 50 frames and 90 samples, sorry, not frames, samples. So we are arrested to start, we have about 120 and 62 45 samples per second. Like here it's 27 samples. This is our rate for global rate for evaluation. We still have a big impact on frame rate, not so big as the ODE engine, but physics also has some impact on probably what finally we have. So that's fine. So now let's go to my realization of using the Newton engine for calculation of these things, and what we probably need for that is adding the ground plane. So here it should work as a static collision. Alright, so we have this frame rate like this, currently 200 or maybe less. Okay, let's run the simulation. Okay, so it's much better, and as we can see, it always keeps the value more than 100. So even in that state, maybe it's not keeping a lot of cubes in one place, sorry, but the performance is really much better, much more productive than ODE or physics. And of course my frame rate is much higher than it was, so now I can see that it's really closer to real time. All these calculations, they are really closer to what I can, a freedom of real time, and there is no any freezes that I can see using the ODE classic engine. So that was just my developer log, and see you in next videos. Bye.